Right, so let's try and solve some problems from chapter 9. For the assignment, the sixth assignment, I think, for this semester. So you guys will have to do number 1, 3, and 6. That's what you have to submit to me. But what I'm going to request is for you guys to also take a look at number 4. So when you've done number 3, also try and solve number 4 from the book, because first of all, it's very closely related to number 3, and second of all, it sort of offers you an opportunity to explore some of the models and equations that we've gone through in chapter 9. So it's a good way of understanding the material, but you don't have to include it in the assignment that you submit to me. Also, you have that one freedom, I suppose. Okay, so let's start with number 2 that I'm going to solve. So number 2 says the medium run equilibrium is characterized by 4 conditions. Okay, the conditions are that output is equal to the natural rate of output, unemployment is equal to the natural rate of unemployment, the policy interest rate, Rn, is such that aggregate demand is equal to the natural rate of output, and expectation, let me write this better, expectation is equal to the actual inflation. So we've already discussed this in the chapter and why they hold. There's nothing new here. So the first part of the question is, if the level of expected inflation is formed so that inflation expectation is equal to inflation of the previous year, or another way of writing this is expected inflation of period T is equal to inflation from the previous period. So if this is the case that we face in the economy, then what behavior can we expect from inflation? Okay, so that's not a difficult question to answer. All we have to do is write down the equation that we have when we express the Phillips curve in terms of in terms of output. We get this change in inflation is equal to alpha by L times Y minus YN. Or we may also write this with the time subscript. So phi t equals to expectation equals to this times output minus the natural rate of output. So they're both are the same thing. So let's just use this one. So if we form our expectation based on previous year's, if we form our expectation of inflation based on previous year's inflation, what we get is this equation right here, which means that if output in the economy is more than the natural rate, we are going to, we can do one more step of simplification. From here, what we get is inflation minus, since we are sticking to this, we get this is equal to. So all we've done is, since the question tells us that expected inflation is equal to inflation of the previous year, we have replaced this with this. And now let's try and interpret what that means for the economy. What it means is that if output is more than the natural rate of output, we are going to see a scenario where inflation this year is higher than inflation in the previous year, which means that inflation is increasing. And if we have a scenario where output is less than the natural rate of output, we see that inflation this year is less than the inflation from the previous year. And what that means is that inflation is decreasing. And I'm sure you guys can work out what happens if this is equal to this. That means that this is equal to this, which means that there is no inflation or deflation. It's fixed at a point. So that was part A, is that if expectation in the economy is such that we expect inflation this year to be equal to inflation in the previous year, then this is what we get. Part B, in part B, what we have is that in the economy, expectation of inflation is formed around a fixed level. So we are no longer looking back at what has happened in the previous years. We are forming our expectation of inflation around a number. So suppose every year the expectation is that inflation will be around 5%. If that is the case, then what will happen? So once again, let's write down the equation first. So we have inflation minus expectation of inflation equals to alpha by L y minus yn. Now, what the question tells us is that expectation is formed around a fixed level. So let's substitute them out, and what we get is inflation minus a fixed level of inflation is equal to y. Now, what does this mean for the economy? What it means is that if output is more than the natural rate of output, inflation is more than the expected rate. So, I mean, of course, we can write down the other scenarios, what happens here and what happens here. That's straightforward. But let's focus on the implications of this. How is this different from this? And for that, I will have to draw the diagrams. Okay. So this is, of course, y. And over here, we are measuring inflation minus expected inflation. Suppose this is what we have. This is the Phillips curve. And at this point, we have yn, which is the natural rate of output. Suppose we are not at equilibrium. Suppose we are at this point, okay? Oh, I've made a mistake. Okay, I'll just draw it down here. So in the book, this diagram is drawn above. I'll just draw it down here. R. So what we get is ice curve. Down here, we will have the LM curve. And right here, we have the interest rate. Okay. So over here, we have the ISLM equation. And over here, we have the PC, the Phillips curve. Okay. Now, suppose the economy is stuck at this point, at point A. Okay. in which case we see that y is more than yn. In the first case, where expectation, so let me just, so I'm going to need more space. So if expected inflation is formed, what's happening here? Expected inflation is formed uh, by keeping an eye on previous year's inflation, then when y is more than yn, we see we've already written this down. Inflation this year is larger than inflation from the previous year. If expected inflation is just equal to a fixed level of inflation, when y is more than yn, we get inflation is just higher than a given level. So what does that mean? That means that if we find ourselves stuck in point A, so of course we are not in equilibrium and we want to go back to the equilibrium. So what will the government do in this case? This is y. We effectively have to reduce y. Okay, I've drawn this diagram a little slightly wrong. This is the control size. Okay. And what will the government want to do if they want to go back to yn? Want to go back to yn? What they will do is they will increase the interest rate. When they increase the interest rate, we end up at this point, which is effectively takes us to yn. Right? So, I mean, up to here, it's pretty straightforward. If output is greater than the natural rate, the central bank increase R, reduce Y, so that Y is equal to yn. So now we've gone back to the equilibrium. Now, if we are in this situation, then that is fine. What that means is our inflation is now equal to a fixed level. So suppose it was 5%. So now we are in a situation where inflation is constantly 5%. It's not increasing, it's not decreasing. If it's 3%, it can be 7%, but it's at a fixed level. So that is fine. All that the central bank has to do in this case is increase the interest rate, and we've gone back to where we were. However, in this case, when we go to the equilibrium, we have a situation where pi is equal to pi of the previous year. Okay, so once again, now from year to year, our inflation is no longer changing. It's not going up, it's not going down. So that would look like a stable situation to us. The problem is if inflation is equal to inflation of the last year. Now, let me write this down. So suppose we're looking at 2016, 2017, 2018, 2019, and then 2020. Okay. So during these 3 years, the first 3 years, suppose we had the case where y was greater than y1. As a result, inflation was greater than inflation of the previous year. So this year we had 6% interest rate. This year we had 8% interest rate. This year we had 10% interest rate. After that, the government increases the interest rate, which reduces y. So now y is equal to yn, and pi is equal to pi. What does that mean? Inflation is no longer changing. 10%, 10%. Inflation year to year is no longer changing. Problem is, this is still a very high rate of inflation. 10% inflation is very high. We do not have that problem in this case. In this case, if the fixed pi is 5, when this is normalized, every year we have 5% interest rate. But in this case, when there is an expectation in play, once inflation gets very high, it stays there. We have merely stopped the rate of change, the difference in growth of inflation, but the actual inflation rate is very high. So what is the solution in this case? The central bank has to increase inflation, not just at this level, but at an even higher level. They have to take it here. If they take it here, this is where we are. So suppose this is y1, this is y2. Let's go up. We're at this point. This is y2. At this point, what is our inflation? Our inflation is negative, right? This minus this is less than 0. What that is going to do is, so to this point, we have a case where this is over here. What we have is this is less than this. So what that will do is inflation will now start to fall. From 10%, we go to 8%. From 8%, we go to 6%. Once we have reached 6%, suppose the central bank decides that 6% is the level where we want to stay at. They're going to bring the interest rate down to the equilibrium level. And now the inflation stops growing. So in 2021, it will be 6%. In 2022, it will be 6%, and so on. Okay, so I'm going to just write down what that, the entire thing, I'm going to summarize that. If expectation is formed around a fixed level of inflation, then what that means is when this is equal, when inflation is equal to that level, there is constant rate of inflation, which is this. But the problem is, if expectation is formed around previous year's inflation, when inflation is equal to previous year's inflation, there is still constant rate of inflation, which is equal to the rate of inflation of the year of the last year when this was not equal to this. So the difference between these two is, as long as we can make sure that inflation is equal to expected level, we have controlled the inflation. But in this case, once we have ensured that inflation is equal to expected inflation, we still have to worry that whether or not expected inflation is too high. If it is too high, then what the central bank has to do is, from this level of inflation, they have to go at a very high level of inflation, interest rate, and from there they have to come down. Okay. So let's see, what was part B? So okay, so part B was pretty short. It was all the way up here. This was part B. But then this is basically the explanation of difference between part A and part B, how the two scenarios differ. And this is very important that you guys understand. So if the explanation isn't clear, please go back to the book, look at this video again, and if it's still not clear, ask me during the live sessions. Okay. Let's take a look at part C now. So the I's relationship is given by C y minus t plus I, which is a function of y r plus x plus g. Okay. The question says that suppose r is 2%, okay, and x is 3%, and it increases to 5%. The question is, how must the central bank change Rn to maintain the existing? Okay, we are in an equilibrium in this scenario. So R is 2, X is 3. And then X goes up to 5. So it goes up by 2 percentage points. As a result, what do we do to R? R has to come down. So R has to go down to 0%, which means that real interest rate has to become 0%. Maintain the equilibrium. That's pretty straightforward. Let's take a look at part D. Suppose G increases. Okay. So in the same equation, G increase. If G increase, of course, you can see from the equation that Y is going to increase. If Y increases, what is going to happen to our ICE LMPC model? Nothing happens to LM. ICE curve shifts to the right. So let's draw this diagram. This is LM. This is IS. That. We have PC. So this is Y. This is Y. This is R. And this is inflation minus. So this is the natural rate. Now, according to the question, G is increasing. Because G is increasing, we're going to notice that the ICE curve is going to shift to the right. So this is the new ICE curve. So let's call it ICE prime. what that means is we end up in this situation where y is more than yn. As a result, we know what's going to happen. There's going to be inflation. So we are at this. So I shifts to the right. Y is greater than yn. As a result, we have inflation in the economy. What's the question? Part D. How must the central bank change the interest rate to maintain the existing medium run equilibrium? Okay. Central bank obviously wants to go back to this point, to the natural rate. How can they do that? What they can do, okay, let me just redraw this a bit better if I can. Suppose this is the ice curve. What the central bank will do is that it is going to it's going to increase the interest rate. What they will do is increase the interest rate to this. So this used to be R. Now this is R prime. This is the new LM curve. So the point where the new LM and the new ice curve intersect is over here, which is once again at this point. So let me just write that down. Since output is greater than the natural rate, leading to inflation, central bank will increase interest rate so that the ice LM reaches equilibrium at a point where output is equal to the natural. When this happens, there is no more any inflation. Y is equal to expected value. So that's the answer. The question doesn't ask for the diagrams. It just asks for the explanation, but I've provided the diagram as well because, well, it's always useful to draw a diagram. And that's one thing for you all to keep in mind, is that during your midterms and the final and quizzes, I won't necessarily ask you to draw the diagram. And if I don't ask you to draw the diagram, you don't have to show me a diagram. But for your own understanding, it always helps to have a piece of paper around and very quickly draw the diagram and to see what's happening. Because its explanation or understanding is always much easier with diagrams. So just keep that in mind for the upcoming questions. Okay, part E. Suppose T decreases. So instead of G increasing, now what happens is T decreases. And so what happens? So if you guys understand part D, you should be able to do part E very easily. So I'm going to leave this for you guys. It's very simple and very similar to part E. So I'm sure you guys will be able to do it. Let's take a look at part F. In the medium run, a fiscal expansion leads to increase in natural rate of interest. Okay. First of all, let's discuss what is fiscal expansion. We've done this already. Fiscal expansion is when government expenditure goes up, where taxation goes down. These are the only two cases when we have a fiscal expansion. And what the question is asking us is to discuss what happens to the natural rate of interest when there is fiscal expansion. Uh, so let's look here. We had an interest rate of R right here, an interest rate of R. Then we had a fiscal expansion. G went up. And because of this fiscal expansion, interest rate went up to R prime. And once you do number E, you guys will see something very similar, is that because tax has gone down, interest rate is going up. So what you guys have to do in part F is just explain the mechanisms. So first talk about what fiscal expansion is. There are two cases, either G is going up or T is going down. And when that happens, explain this entire mechanism, explain what happens and then who reacts how and what role expectation plays. And as a result, natural rate of interest must go up. So just explain in your words. So once again, I'm sure you guys will be able to do it quite easily. So the next problem I'm going to solve is number 5 right here. So let's do that in a separate video.